Greetings to my dear students. In this video, we are going to continue the problems regarding Cauchy's theorem and Cauchy's integral formula. That is evaluation of integrals, definite integrals using Cauchy's theorem and integral formula. Okay. So here, up till now, they have given the simple closed curve as a circle, but here instead of circle we are having a square. Okay, it's also a simple closed curve. So given that, let us see denote the boundary of the square whose sides lie along the lines x equal to plus or minus 2 and y equal to plus or minus 2, where c is described in the positive sense. Okay, so 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 this is our real axis. Okay, yeah. Okay, this is our real axis. Okay, so this is our real axis. Here x equal to, we have four lines here, x equal to plus 2 and minus 2, y equal to plus 2 and minus 2. Okay, so yeah, so this is 1 and this is 2. Okay, so this is minus 1 and this is minus 2. Similarly, this is 1, this is 2, and this is minus 1 and this is minus 2. Okay, okay, so first line is x equal to 2. So x equal to 2 means this part, isn't it? So x equal to 2 means this line. Okay, similarly x equal to minus 2, x equal to minus 2 means this line. And next, y equal to 2, so y equal to 2 means this line, and then y equal to minus 2, so this line. So what is the simple closed curve? It is the closed curve the boundary of the square. Okay, so which means what is our yeah, what is our region, the intersection of these four lines, that is this square. Okay, so this is our region. This is our region C. Okay, so here they have given two subdivisions. First one, evaluate integral over C Z by 2Z plus 1 dz, and the second one is integral over C cos Z divided by Z into Z square plus 8 dz. So we will see one by one. So first we consider the first division, that is integral over C Z by 2Z plus 1 dz. Okay, so by using Cauchy's theorem and Cauchy's integral formula, the denominator part should be which form? Some z minus z naught. Okay, this is the form the denominator should have. But here we have 2z plus 1. Okay, 2z plus 1. So what we are going to do is we are going to make this as this form. Okay, we are going to make this as this form. How we can make this? Okay, so here we have 2z plus 1. Okay, 2z plus 1. So we need to have the form some z minus some minus z not something. So we are taking 2 outside. So by taking 2 outside, what is the remaining thing we get? Z plus 1 by 2. Okay, z plus 1 by 2. So this is equals to, if you want to write as z minus z naught, then you can rewrite this as minus of minus 1 by 2. Okay, so this will become 2z plus 1 will become 2 into z plus 1 by 2 or 2 into z minus minus of 1 by 2. Okay, so whatever it is, you can, whatever form you want, you can write, take it. Okay, okay. Yeah. So the integral over c, this will equals to this. Here 2 is a constant term, so we are taking out of the integral. So 1 by 2 into integral over c z by z plus 1 by 2 into dz. Okay, so now it's in the form as in the Cauchy's integral formula. Okay, so here what is the value of f of z? F of z is equal to z. Here, at which point the singularity, sorry, analytic fails at minus 1 by 2. At z equal to minus 1 by 2, the what fails? The analytic fails. So next, we are checking whether this point z equal to minus 1 by 2 lies inside the curve. So z equal to minus 1 by 2. So minus 1 by 2 is somewhere here. Minus 1 by 2 is somewhere here. So it lies inside the circle. So therefore, by Cauchy's integral formula, integral over this is equal to 2 pi I into f of minus 1 by 2. Here is that not as minus 1 by 2. So f of minus 1 by 2, it is equal to, what is f of z? F of z equal to z. It identity mapping. Z goes to z. So therefore minus 1 by 2 goes to minus 1 by 2. So it is equal to 2 pi I into minus 1 by 2, which is equal to minus pi I. Okay. So the integral value of this is equal to minus pi I. Okay. So we have completed the first one. So now we are moving into the second part. That is integral over c cos z divided by z into z square plus 8 dz. So we can solve this problem. We can evaluate this problem by two methods. Okay. Either you can choose first method or second method. I will show you. I will teach you one by one. Whichever it is convenient for you, you can take that. You can take that one. Okay. Yeah, integral over c cos z by z into z square plus 8 dz. Okay, so as usual, because the denominator part contains is not in the form z minus something, we have to do the partial fraction and make it into the z minus z form. So here we have three terms, because z square plus 8 can be written as in the last video I have shown z square plus 4. So here we have z square plus 8. Okay. So let z square plus 8 is equal to 0. So this, from this we get z square equal to minus 8. So therefore z equal to plus or minus square root of minus 8, which is equal to plus or minus, sorry, okay, plus or minus square root of minus 1 into square root of 8. Square root of minus 1 is equal to I. So I square root of 8 can be written as 4 into 2. Okay, 4 into 2. 4 can come out of the square root. That is square root of 4 is equal to. Again, you can skip this line. If you know the answer directly, then you can skip this line. That is square root of AB is equal to square root of A into square root of B. Square root of 4 is equal to, we know that this root, sorry, 2. So plus or minus, this is I, and 2. Square root of 2 is square root of 2 only. We cannot simplify that one. So therefore, Z equal to plus or minus I2 square root of 2. So we have two values, plus I2 square root of 2 and minus I2 square root of 2. Okay. So z square plus 8 can be written as z minus I2 root 2 and z plus I2 root 2. So here we have three linear equations. We have three linear equations. In the previous problems, we have only two linear equations, and here we have three equations. Same as the two only, okay? Since we have three linear equations, we are taking three, we are splitting into three. Okay, that is a by z plus b by z minus I2 root 2 plus c by z plus I2 root 2. So therefore cos z by z plus this is equal to this. So next we are taking the LCM. We get this part. Okay. By taking LCM, we get this one. So next, these two will get cancelled. Therefore, cos Z is equal to, so cos Z will becomes A into Z minus I2 root 2 into Z plus I2 root 2 plus B into Z plus I2 root 2 plus C into Z minus I2 root 2. Okay. So, when I substitute as Z equal to 0, because we have three values here, 0, I2 root 2 minus I2 root 2. When we substitute Z equal to 0, A, B and C will vanish. We get the value of A. When we substitute Z as I2 root 2, A and C will vanish. We get the value of B. When we substitute Z equal to minus I root 2, A and B will vanish, we get the value of C. Okay. So when Z equal to 0, cos 0 is equal to BC will vanish. So A into minus I2 root 2 into I2 root 2, which is equal to 8. Cos 0, the value of cos 0 is 1. Therefore, A is equal to 1 by 8. When Z equal to I2 root 2, A and C will vanish. So therefore, cos of I2 root 2 is equal to B into I2 root 2 into 2I root 2, because here I2 root 2 plus I2 root 2 is equal to 2 times I2 root 2. Simplify this, we get B is equal to minus 16. Note that I square equal to minus 1 is all we know that the value of I square is equal to minus 1. Okay. So that's what we get minus here. So therefore, B is equal to this one. When we substitute Z equal to minus I2 root 2, we get C equal to this. Okay. So we found the value of A, B and C. Now we are going to substitute the value of A, B and C via here. Okay. So we are taking this cos Z by Z. Z into Z square plus 8 is equal to the value of A by Z, the value of B by Z minus I2 root 2 plus value of C by Z plus I2 root 2. Okay. Next, next step is we have to take the integral on both sides. Okay. By taking integral on both sides, we get integral over C cos Z divided by Z into Z square plus 8 dz is equal to first integral, second integral and third integral. Now we are going to find the value of these three integral one by one. Okay. So in this integral, as this is the constant value, we are taking outside the integral. So therefore, this will become this. Okay. Okay. Now consider the first integral. What is the first integral? Integral over C 1 by Z. Here, what is the value of f of Z? F of Z equal to 1. The point in where the analytic fails is 0, which lies inside the square C. It's clearly, isn't it? Because we have the square, the simple closed curve as sorry. So this is our simple closed curve. This is minus 2, minus 2, plus 2, plus 2. Okay. Okay. To precisely, this is our real axis, and this is x equal to, yeah, this is x equal to 2. This is x equal to minus 2. This is y equal to minus 2, and this is y equal to 2. This is our square, isn't it? Here the point is 0, 0. This is 0, isn't it? Sorry. This is 0. So the point lies inside the square C. So we are applying Cauchy's integral formula. Therefore, integral over C 1 by Z dz is equal to 2 pi I into f of 0. Since f of Z equal to 1, f of 0 is also 1, which is equal to 2 pi I. Okay. Okay. Here we have 1 by 8 here we have 1 by 8 in integral over this. Already we found the value of this. So now we are multiplying by 1 by 8. So 1 by 8 into integral over this is equal to 1 by 8 into 2 pi I, which is equal to pi I by 4. Okay, you can do the thing. When you can multiply the value of this by 1 by 8 in the last only. If you want, you can do it here, or otherwise you can do it in the last. Okay, when we substitute the value of these three integrals, in that place you can multiply by 1 by 8 and multiply by this and multiply by cost value. Okay, so now consider second integral. What is second integral? 1 by z minus I to root 2 dz. Okay, so here f of z equal to 1. Okay, so now the what is the point the analytic fails at z equal to I to root 2. So now let us check whether this point lies inside or outside. Okay, so the value is I to root 2. Okay, so I to root 2 means 0. The point z can be written as is. Okay, so z is equal to I to root is can be written as z plus I to root 2, isn't it? It is nothing but 0 comma I to root 2. So we know that value of root 2 is 1.414 is something, isn't it? So the value of root 2 is 1.414. When we multiply 1.414 by 2, it will become more than 2. We will get some 3 point something. Not 3 point something, but 2.8 something. So we get some 2.8 something. But this point, so this is equal to 0 comma 2.8. Okay, 0 comma 2.8, which lies outside the square, because 2.8 is up to this only we have 2. So 2.8 somewhere here, it is lies outside the circle, outside the square. Therefore, by Cauchy's theorem, the integral value will become 0, because at all the points inside the square, the function is analytic. The only point where the functions are not analytic is I to root 2, but that point lies outside the square. It's not going to any trouble for the function 1 by z minus I to root 2 over this curve. Over this curve, this is not going to give any trouble. Okay, since the only point where the analytic fails lies outside the square, now we are taking the integral over this simple closed curve only, but this point lies outside the curve. So by Cauchy's theorem, all points the function is analytic at all points inside and on the curve. So therefore by Cauchy's theorem, integral value is 0. So next consider third integral. Here the analytic fails at minus I to root 2. Similarly, minus I to root 2 is equal to 0 comma minus 2.8. So minus 2.8 is somewhere here. This is also lies outside the square. So therefore by Cauchy's theorem, this integral value is also 0. So except the first one, the second integral and third integral will become 0. So now we substitute the value of these three integrals in via this part. Okay, in this place we are going to substitute the in this place we are going to substitute the value of. So therefore integral over c cos z by z into z square and dz is equal to 1 by 8 into value of this. Since the integral of this is equal to 0 and this integral of this is equal to 0, these two will omit, will get cancelled. Okay, so the remaining thing we have is integral over c f of z, sorry, cos z divided by z into z square plus 8 is equal to the value of first integral. Already we have found the value of first integral and we multiplied by 1 by 8, which is equal to pi I by 4. So therefore integral value is pi I by 4. So this is first method. Okay, the second method is so simple. Okay, so look at the second method. So the z by z square plus 8 can be written as, we know that already we saw in the method 1, z into z minus I2 root 2 into z plus I2 root 2. Okay. Note that this I2 root 2 and minus I2 root 2 lies where? Outside the square, isn't it? These 2 points lies outside the square. So what we are going to do is, we are going to take the function f of z as, in the previous method, we have taken f of z as cos z itself. Okay, we are take f of z as cos z, and then we did the partial fraction, and it will become like this. Okay, and it is becomes like this. The value of this becomes like this. Okay, but here in method 2, as these 2 points lies outside the circle, we are taking f of z as cos z by the cos z by this. Okay, instead of taking cos z alone, we are taking the function f of z as cos z by this term, because these 2 points lies outside the circle, outside the square, sorry, outside the square. So it will not going to make any changes in the Cauchy's integral formula, since it lies outside the square. So instead of taking f of z as cos z, these 2 points outside the circle, outside the square, I'm taking the f of z as cos z by these 2 terms, which is equal to what? Z square plus 8, because we have splitted z square plus 8 only this. So I am taking f of z as cos z by z square plus 8. So now the integral will become how? The integral cos z by z into z square 8 dz will become cos z by z square plus 8. I am taking z square plus 8 into the numerator part. Okay, I am taking the z square plus 8 term into the numerator part, and in the denominator part we have only z. So therefore, by Cauchy's integral formula, because the point 0 lies inside the square, in where the analytic fails. So, by taking z square plus 8 into numerator part, we can use Cauchy's integral formula for the point 0. Okay, so therefore by Cauchy's integral formula, we get integral over c cos z by z square plus 8 into dz is equal to 2 pi I into f of 0. So here f of z is equal to f of z is equal to cos z by z square plus 8. Okay, so substitute 0 in the place of z. F of 0 becomes cos 0 by 0 plus 8. So value of cos 0 is 1, therefore 1 by 8. So therefore 2 pi I into 1 by 8 is equal to pi I by 4. Instead of doing all the partial fraction, it is the easiest method to find the integral value. If suppose if the point lies outside the circle or outside the square, means you can take that part into f of z. Okay, you can take that part more, what to say, you can choose that function into f of z. You can consider f of z as by including that one. If it is lies outside the circle, means if it is lies inside, then we must do the partial fraction. Okay, if it is lies outside, means you can move that part into the f of z. Okay, you can change, because f of z, this is what we can choose, we can take as I want, because in the denominator part I only have z minus something, the remaining things I have to take it as f of z only. Okay, so if it is lies outside, means I can take that part into f of z, that's all. Okay, so this is the easiest instead of finding all the partial fraction and finding the value of integral separately. This is the easiest method. Okay, so I hope this problem is clear to you all. Yeah. So we have only one problem left in this section. We will see it in the next video. Okay. Thank you, dear students. Thank you.